All right, let's look at the expected value, variance, and the standard deviation. All right, so it's probably the easiest to dive right into an example to demonstrate these things. All right, so let's say you have a random variable, and the possible values are 1, 2, 3, 4, 5. And we listed its each probability. So probability of getting a 1, x equals 1 is 0.4, probability of 2 is 0.2, and so on. Right, so the data is given. Right, then we want to find the expected value of this random variable. Right, expected value is essentially the weighted average. Right, so what you do is for this example, right, so 1, right, so 1 is have the 0.4 probability of happening. So you multiply 1 by 0.4 plus, and 2 times its probability, so it's a 0.2, and 3 times 0.2 plus 4 times 0.1 and plus 5 times 0.1. Then we just have to add them up, and I'm going to use a GeoGebra to compute it. All right. So we're going to just type in. I'm going to actually do a little bit of mental computation too. All right, 1 times 0.4 is 0.4. All right. 2 times 0.2 is 0.4 again. And 3 times 0.2 is 0.6. And 4 times 0.1 is 0.4. Plus 5 times 0.1 is 0.5. Right, so hit enter. All right, so it's a 2.3. So expected value is 2.3. All right, so we got that. All right, so that's how you find the expected value. All right, variance is expected value of the square difference from the mean. So if you write it in terms of expected value, so this is expected value of the square difference. So we take the difference between the x value, random variable value, then minus the expected value. So it's going to be 2.3, right? And then you square that. All right. All right. So maybe we should make a list. So here. All right, so I'm going to make a list of square difference. All right, so the square difference would be, I'm going to just do x minus expected value 2.3, then square that. All right, so here, all right, so 1 minus 2.3 is 1.3. So it's going to be 1.3 squared. Right? All right, it's let's see, 2 minus 2.3 is negative 0.3 squared. So I'm going to just say 0.3 squared because negative is not going to matter because it gets squared anyway. All right, so it's let's see, 3 minus 2.3 is 0.7 squared. Right? And 4 minus 2.3 is 1.7. Then you have to square that. And 5 minus 2.3 is 2.7. And square that. All right. Then you just need to find its expected value. So all you have to do is, right? So value is 1.3 squared, but the probability is 0.4. Right, then you have a 0.3 squared. Probability is 0.2 plus 0.7 squared times probability is 0.2 again, plus 1.7 squared, and then probability is 0.1, and the last one is 2.7 squared, and the probability is 0.1. Alright, so exactly the same way, so it's expected value of the square difference from the mean. Alright, then let's compute this value. Alright, so we have 1.3 squared times 0.4 plus 0.3 squared times 0.2. Right, I guess maybe I'll just stop writing 0 plus 0.4 squared times 0.2 plus 1.7 squared times 0.1 plus 2.7 squared times 0.1. Right, then hit enter. Right, so it came out to be 1.81. So 1.81 is the variance. Right, and variance is actually the square of the standard deviation. So if you want to find the standard deviation, all you have to do is, so this is actually the same thing as standard deviation squared. Right, then expected value. Let's see, so here, so square root of the variance. Right, so this is just going to be a square root of, which we have 1.81. And what number is that be? So you have a square root of 1.81, which come out to be 0.35. Is that an exact value? Let's see. I'm gonna just change the rounding and see if it's okay. It's not the exact value, but so this is about here. Let's see. Oops. 1 point. I'll just say 1.35. About 1.35. Right. So that's the standard deviation of this data set. All right, that's it. I hope that this was clear.